The ready, set, go for lesson 4.3 it's very long. It seems like a lot, but when we go through it, there's really not a whole lot to the problems. They're very concise problems. So for numbers 1 through 7, it's asking you to perform operations on -9 is less than 2. And I'm just going to go through 3 of them to give you a little bit of a head start. So for number 2, add 15 to both sides. Well, you would take -9 plus 15 less than 2 plus 15. This would get us 6 is less than 17, which, yes, that is definitely true. If I were to, let's go look at number 4. Multiply both sides by 10. So -9 times 10 is less than 2 times 10. Would have little arrow here. Like -90 is less than 20, which, yes, that is definitely true. Number 7, divide both sides by -3. -9 divided by -3 is less than 2 divided by -3. So when I divide this out, I would get -9 divided by -3 is +3, and 2 divided by -3 is, we'll just say -2/3, or you could say -0.666 repeating. And 3 is not less than that. That is false. So that's the big thing that we're working through here, and it's going to take some time, but that is the overarching theme of that, numbers 1 through 7. For the set portion, again, working through what we had practiced during the lesson itself. So I'll do just a few of the even problems here. Solving for h, we would need to find a way to get rid of all of this to isolate that. So all of this is multiplied by h, so the inverse of multiplication is division. It doesn't matter what it is. It could be smiley faces, rhinoceroses, numbers, letters, shapes. I need to use the inverse operations, which would end up giving me h equals q over pi r squared. Solving for m. If I wanted to solve for m here, I need to work outside to in. So the first thing I'll do is subtract b on both sides. Y minus b equals mx. And getting m isolated, we would divide both sides by x. So we would have m equals y minus b all over x. Number 14, solving for z. Again, working outside to inside. So the w is the furthest thing away. I need to divide both sides by w. And we would have a over w equals z plus 7. We would subtract 7 on both sides. And this one's the tricky part. Okay, I'm not going to go a minus 7. It would be a over w all minus 7. Something to keep in mind there. One more. Number 18 is a little bit funky. So we want to solve for x. We want to make sure that we get this all by itself. We'll work our way outside to in. We have 2x over 5 equals 6 plus 9y. Then we would multiply both sides by 5 over 2. And just distributing that in, we would get x equals 5 over 2 times 6 is 30 over 2. And 5 over 2 times 9y would be 45y over 2. So simplifying it down, you could have 15 plus 45 over 2y. Or you could leave it as 45y over 2. There's a lot of stuff happening there. The big step that I think a lot of people get mixed up on, or will get mixed up on, is this 5 over 2 distributing back into the problem. So hopefully that helps a little bit there. For the go, we're going back in time looking at x and y intercepts. So our x-intercept is where our y value is 0. That's it. Our y-intercept is where x is 0. That's it. So I don't feel like I need to do 22 and 23. Just keep an eye on 21 and work through those as needed. All right, for the last portion of the go, I'll do number 27, 28, and 29 just to give you a little bit of variety, but not too much here. So for 27, the first thing that we're going to do is, again, we're going to work our way backwards. So we've got 3x plus 11, find the inverse of 11. And this is the addition property of equality. And we would have negative 27 equals 3x. From there, we would divide both sides by 3. And that's the division property of equality. And we would end up with x equals negative 9. I'm not going to go through the justifications. You're going to have those. I'm just going to go through the left-hand side. I'll leave the right-hand side for you to be able to discuss. So just know that it's there. It is helpful to be able to understand what each step is doing and why. I want to make sure that you get the chance to see how. So we'll work backwards. Instead of a positive 6, we'll take a negative 6 to both sides. 10 minus 6 is 4. Divide both sides by negative 2. We would have x equals negative 2. And number 29. I'm going to try to get the x on the left-hand side of the equation, just because it's cleaner for me. So we'll try to clear everything else away from it. 6x equals x plus 15. We'll subtract x to both sides. Oop. And then divide by 5. So this is an example of 3 different problems. I know it's not all of them, but hopefully it's enough to get you started in the right direction. Hopefully this helps. Reach out if you have any questions at all. Thank you.